Coming class, so on Wednesday we stopped here, so I will just start from this point for Friday's lesson. So we know we discussed for any open channel flow there can be three different zones based on yn, which is the normal flow depth, and yc, which is the critical flow depth. And we also learned that there can be different types of channel, like mild, critical, steep, horizontal, adverse, something like that. So based on that, the orientation can be different, like the yc and yn, but there will be always three zones. So let's discuss that part. So let's just for this example, let's discuss, just think about the positive slope, mild and critical. So for mild, we know that yn is greater than yc, and for steep, we know that yn is greater than yc. Okay, so just let's consider the channel we have, that is actually a mild channel. So this line, this will be yn, this line will be yc, here y equals to 0, and the upper limit of y, that is actually the infinity. Okay, if we consider this slope, this channel is a steep bed slope channel, then this one will be yc, this one will be yn, this one will be y equals to 0, and obviously this one will be y equals to like infinity. Okay, now for zone 1, zone 2, zone 3, so this one is the zone 2, zone 1, this one zone 2, zone 3. If I want to identify the upper limit and lower limit for each zone, then for zone 1, obviously the upper limit equals to infinity, lower limit obviously for yn if it's mild, and yc if it's steep, right? For zone 2, obviously this one, zone 2, so it's the upper limit for this zone 2 is yn for mild channel, or yc for steep channel, and the lower limit yc or yn. Okay, now zone 3, the upper limit is yc for mild channel, or yn for the steep channel, and lower limit is 0 for any type of channel. So basically these will be like any channel, there will be maximum 3 zones, but we will see for some type of setup we may don't have the zone 1 or zone 2, we will discuss that, but in general any channel should have these 3 zones. And we also learn different type of water surface profile, and I discussed that in class, that for zone 1 and zone 3 we will always get backwater profile, but for zone 2 we will always get the drawdown profile. Okay, so these are just examples of all the water surface profile is possible. Okay, so how do we name different type of water surface profile? So the naming of water surface profile, there will be first letter of the slope type and the zone number. Okay, suppose we are trying to find the water surface profile for mild slope for zone 1, so that will be m1. Similarly for zone 2 mild slope, m2, m3. For steep slope it will be s1, s2, s3. For critical, c1, c2, c3. For horizontal, h1, there is no h1, so h2, h3. And for adverse, a2, a3. We'll discuss why there is no h1 and a2. Now if you look at all the profiles, you will see that they have little bit different shape. So there are some reasons, and from the governing equation of the gradually varied flow, we can actually say when the y is infinity or tends to infinity, water surface is horizontal. Okay, so here you can see they are becoming horizontal. Okay, when y equals to yn, water surface is parallel to the channel bed. Like here, y is equal to y or close, like tends to yn, so it's actually parallel to the channel bed. When y equals to yc, water surface is perpendicular to the channel bed. So you can see here it's perpendicular, so whenever it's close to yc, it will be like perpendicular, and y is when the y equals to 0, the water surface makes certain angle with channel bed. That's because this one is not obviously possible. When y is 0, that means there is no water surface. But just theoretically, if we want to find out the shape of the water surface profile, basically they make a certain angle here, and there is no specific rule for that. So that's why when y equals to 0, this one will make a certain angle with the channel bed. Okay, now in total we have 3, 6, 9, 11, 13 profile. Okay, now the question, why the C2 profile is a straight line? If you look at here, this is a straight line, there is no shape. That's because C is actually for C2 is critical slope zone number 2. Now if you can remember zone number 2, that is actually a zone between yc and yn for any type of slope, mild, steep or critical. And for critical slope, we also know yn equals to yc. That means the zone 2, that is actually kind of like non-existent, and that's why for C2, since yn equals to yc, so NDL and CDL line is the same lines, there is actually no zone 2, like separate zone 2. That's why it's a straight line. Okay, then few more things why we don't have the A2 profile. That is another question, why don't we have the A2 profile? Now for explaining that, we need to come up from this relationship. If you can remember, we discussed a little bit about the conveyance, k equals to kn s naught. Okay, so s naught is the bed slope here. Now for adverse channel, that s naught, that is actually negative, right? Because it's the negative s naught, it's going against the direction of flow. Now if you rearrange this equation, it will be kn q over s naught, which is s naught and q, like they are one function of yn. Okay, now for this one, if the s naught is negative, obviously root over negative, you know that's not a real number, and that's why it's basically non-existence, like there is no existence of A2 profile. The same thing for horizontal channel also. So the same thing here. Now s naught is 0 because that's why it's horizontal. Now q over 0, root over 0 or something over 0 is obviously the infinity. So this whole thing is infinity. That means the A2 profile, that is somewhere in infinity. So that's why we don't have the A1 profile also. So this can be 2 extra credit questions in your test, that why don't we have the H1 profile, why don't we have the A1 profile, or why the C2 profile is a straight line. Okay, now once we know all the different types of shapes and how they will behave at different depth, now it's time to do the computation of water surface profile for gradually varied flow. Okay, so when we say computation of water surface profile, that simply means, suppose this is a channel and we have something here, maybe a dam or something, and water is backed up here. So this is a backwater profile. There can be different types of other profile also, like the drawdown profile. Now the here, like from any specific point, either from dam or from the downstream, something like that. This is the delta x, and at each one, maybe this one is y1, this one is y2, this one is y3, this one is y4. So finding, and if you start x is equal to 0 from here, so here it's x1, x2, x3, x4. So finding that y1 and x1, y2 and x2. So basically, to finding the coordinates of these points, that is actually the water surface profile computation. So there are a number of methods. I listed 4 methods here, but for this course we will only discuss this direct step method. So let's discuss the details of the direct step method. So for direct step method, basically, if you know the y upstream and y downstream, you can find just from the previous examples here. Suppose you know this one is y1 and you know y2. Okay, so what you will basically do, you will divide this whole section into some part here. Okay, so this one is y1, this one is y2. You can say this one is y11, 1 2, 1 3, 1 4, and in between y11 and y1 the distance is delta x. So if you know the upstream and downstream depth, suppose this one is 3, this one is 2, so you can actually assume the next step like y1. Maybe you will say, okay, I will go from 3 to 2 by 0.2 increment, so it will be like 2.8, 2.6, 2.4, 2.2 and 2. Okay, now the task is you need to find the delta x. That basically means you know the y, but you need to find at which distance you will get that y. So this is the equation here. Okay, and this is applicable for prismatic channel. Prismatic channel means when the cross section is not changing along the length. Okay, so for this one, E1 and E2, those are specific energies. S0 is the bottom slope, you already know that, and SF prime, that is actually the average friction slope. So what is the average friction slope? Average friction slope is the average of 2 friction slope and two adjacent section. Okay, and in general SF is, we know, HF over delta X or L. Now the question is how to find this one, this SF or HF, how can we find this one? So that's what we will discuss here. Basically, you can find that from the Manning's equation. Okay, so if you can remember what was Manning's equation for SI system, the Q equals to 1 over N A RH 2 over 3 SF. So you will just rearrange this SF, Q, N. So that is the SF, and you can do that for section 1 and section 2. So once you have everything, then you can actually calculate this delta X and you can move on to the next section. And that's what we will do for class example 19. That will be a separate video. So for this class lecture, you will have this video and the class example 19 videos. Thank you, class. I will see you on Monday.